All right, this problem takes us through several different steps of the t-distribution, and the first thing we need to do is grab a sample. So when we're trying to calculate the confidence interval, we need these things right here in order to use the formula. The sample size, we have the number of people here. Point estimate is always our best guess at the population parameter. In this case, we want the population mean. So the sample mean is our best guess at that population mean. Sample standard deviation we're given. Later we'll calculate that ourselves. And then critical value. Critical value, so if you think about the confidence level you want, 99%, then you take the area that's not confident. So if 99% is confident, that leaves 1% not confident. That's called our alpha. That's the chance that we're not going to catch the population mean with our particular interval. And so that 1% could be because we guessed too high or because we guessed too low. So we have to split it in two. So that 1% actually gets split, divided by 2 to get 0.005. And that's the subscript that we would use to get our critical value here. So that's 2.921. You could also type that in. If they didn't give you those tables, you could just type in 0.005. And then degrees of freedom, we'll look at it in a different problem, but it's just one less than the sample size. So that also confirms our 2.921 there. Okay, so we use that, we get our confidence interval right here. So again, best guess at how far these people, the distance from each voter's home to their nearest polling station. So 4.179 is our best guess, but we know it's plus or minus 1.44 miles. We're 99% sure that the true distance, average distance, is somewhere in there. So we're going to enter these values in. We're going to take that, we're just going to do that off to the side here. Subtract 1.434. That's going to give us 2.745. Press enter. I guess I might as well just do it here. Why do I need to do it off to the side, right? So here we're going to do 4.179 plus 1.434, and this gives us 5.613. And then it says the population mean, which we don't usually know. Oh. Something's off there. All right, we will keep following this out, but that's rare for a population value to be that far outside of a 99% confidence interval. But let's go with it. Let's see what happens. All right, does it contradict the claim? It does contradict the claim. So anytime that your population value is outside of the confidence interval, it does contradict the claim. So it's outside the interval, which means it contradicts the claim. If it's inside here, then it's, well, yeah, that could be a reasonable average, but 7.78, that's way outside. Okay, I see. That's why we got so far outside, because the claim was that it was 7.78. And then obviously that claim is wrong, so that's why it was so far outside of the confidence interval here. All right. Notice this is, I had just been doing several where you have the actual population mean that the samples were drawn from, and there's like a red bar and you're getting them around. That's a different situation than this, because the whole point of this is this sample was not taken from a population where this was the mean. And that's what we're going to be getting into in the next few weeks with statistical tests. So we'll double check this.